welcome back to an episode of the Open Source Cafe. My new background because I just got my desk today, so I'm very happy. And we have Eden joining us today from Odigos. We're talking about OpenTelemetry today, and we're going to talk about application performance monitoring. So, very exciting topic because it can get a bit complex, and that's what we're here to solve. And we are huge promoters of open source. I mean, my community, myself, Eden and his community. So we're going to share some open source tools as well, like Odigos, to help you, in your journey. By the way, the links for that can be found in the description below. And since it's open source, the community is thriving. So they're very close to 3,000 stars. So you can, start the repository and check out the open issues, try out the project, and just give feedback, get involved in the community, create value. It's open source, and that's why we're here. But Eden, would you like to give yourself a quick intro and what you do?
Sure. So, hi, first of all, thank you for having me. Excited to be here. A little bit about myself. So, I'm currently the CTO at Odigos. Previously to that, I created a couple of other open source tools. I created a profiler for Kubernetes called kubectl Flame, which is pretty big success, I think. Also, my past with monitoring tools goes way back. I created the monitoring tools at companies like Yahoo, for example. And I'm currently also one of the contributors to OpenTelemetry, especially in everything related to the Go automatic instrumentation special interest group. Yeah. That's about it.
Amazing. So you mentioned, you obviously have such a vast experience, and I want to talk about OpenTelemetry a little bit. So let's directly jump on to the enterprises, right? Because that's where we see most of the, pain points. So from your experience, what are some of the common challenges or pain points that you have seen associated with implementing OpenTelemetry in an enterprise environment?
Sure. I think there are three main big challenges, especially when dealing with large enterprises and large distributed environments. The first one is that instrumentation itself, just the act of extracting data, telemetry data from your application, it can be a very big, very large task, especially if you are dealing with languages that does not have a lot of automatic tools. So imagine you have thousands of Go microservices. You have to go to every microservice and do a lot of code changes, add different APIs and SDKs, and really instrument your application, change the application code to generate all this data, all this telemetry data. So instrumentation can be a very manual process. Again, I think that there are some automatic solution to some languages, like in Java. I think, for example, there is a very good automatic solution, but again, because of all the promise of microservices combining multiple languages, I think that, again, going into this large project of now instrumenting hundreds and thousands of microservices can be a very long journey. I think that's like the first main issue. And of course, the larger the environment, the larger is going to be the task of instrumentation. The second issue is everything related to collectors. So I don't know how much people are familiar with OpenTelemetry, but basically in order to generate traces, metrics, and logs, there are three parts to it. You need to generate the data, instrumentation. You need to buffer it on your cluster in some agent and some collector. In OpenTelemetry, this is called OpenTelemetry collector. And finally, you need to send it to some external system like Jaeger, Grafana, Datadog. There are many other observability vendors. And basically, the part in the middle, the collection, is usually being done, again, if we're talking about OpenTelemetry, is done by a component called OpenTelemetry collector, which is an amazing piece of software. It can do so many things. It can include so many features, from sampling to rate limiting to filtering to adding additional data. But all these great features come with the big disadvantage of just configuring this piece of technology, this OpenTelemetry collector. It's been done by specifying a very large YAML files, and there is a lot to learn here in order to really know how to use the OpenTelemetry collectors in the right way. And the third part, which is something that we keep hearing, again, especially from very large organizations that are more performance sensitive, is that sometimes, especially automatic solution, like the automatic solution for Java, for example, the automatic instrumentation can cause a severe performance overhead on their applications. So again, I think this is also something that holds organization back from adopting open source project like OpenTelemetry.
Well, thanks for sharing, Eden. And when we talk about, we're talking about performance monitoring. So, with the complex complexity of, let's say, distributed tracing, you extensively, let's say, require sometimes various code changes or whatever. So, how does OpenTelemetry address this complexity of distributed tracing? Let's say if we do want to do it, let's say, without requiring too many like extensive code changes.
Mm-hmm. So again, there is a solution that is very dependent on the programming language that you are using for. So for Java, for example, there is this Java agents you can add to your application, which will do most of the instrumentation automatically for you, especially everything related to open source libraries like Kafka, Cassandra, AWS SDKs, for example. I think in Python and JavaScript, there are also some automatic instrumentation solutions. Every solution, the maturity and the stability of the instrumentation is a little bit different. And I think the hardest part is in compiled languages like Go, C++, Rust. This is where it's very hard to create automatic instrumentation using the regular OpenTelemetry tools. And I think a big part of like automating this whole instrumentation part and generating distributed tracing, in addition to something that is called context propagation, which basically this is what creates the traces, the ability to propagate the context between different requests. This is a big part of what we're trying to achieve here with Odigos, like giving you those automatic instrumentation experience that no matter what programming languages you are working with, you will automatically get distributed traces without having to think about instrumentation at all.
Thanks for sharing, Eden. And one other area that I want to talk about is, especially when you're implementing OpenTelemetry, is there any performance overhead that organizations may encounter when they're adopting OpenTelemetry, and how can these be mitigated?
Sure. So I think it really depends on the signal. So take logs and metrics, for example. The performance overhead is usually pretty low because like you add a new log line and basically your logger is basically appending it to some file in the local hard disk. And that's it. That's all there is to do in logs, for example. Metrics, if you are working with something like Prometheus, again, because it's like just a single number, a simple aggregations that you are doing. Again, given that you are not using some very high cardinality metric, also the performance overhead should not be a problem. I think where performance issues really arise is when you're generating distributed tracing. So think about it that unlike metrics and log, traces is something that is more stateful. You have to like collect a bunch of spam, store in memory, batch it, and then send it out to external system like the OpenTelemetry collector, for example. So think about it, and especially in languages which are like single-threaded, for example, like JavaScript. Just the fact of now generating distributed traces makes your application do a lot more work. So you now have to store all those different spans in memory and queue it up and then serialize it into some protobuf or JSON and then send it out to external system. This is all a lot of new work that your runtime, that your application now have to do. And sometimes this can cause processes like garbage collection, which are process-wide and affects the whole application, really cause them to do longer pauses and deal with more data, which overall increases the performance latency of the application.
Understandable. And when you know when you're implementing OpenTelemetry, can you also maybe share in order to do it right, what are some of the key considerations for ensuring that OpenTelemetry implementation is successful in maintaining like superior application performance monitoring?
Sure. So again, I think that this is true for any monitoring pipeline and monitoring solutions that you are building. You first have to make sure that the data is good, that the instrumentation is very solid, everything is exported in the, if it's OpenTelemetry, in the right semantic conventions, that you have a good coverage of the open source libraries that you are using, of your business logic code. So you really need to have a very uh, good, solid instrumentation that exports a lot of data and useful data, not just like vanity metrics, but really useful data that lets you debug the application. The second part is that how you make sure the pipeline itself, the transmission of all this great data from your applications to the external system is scalable and is solid again, and it's able to scale up and down according to the amount of traffic, how you're handling if one scenarios for, let's take for example that one application is very noisy and produces most of the telemetry data, how you make sure that other applications are not affected, and how you make sure that again using something like OpenTelemetry collectors and maybe a project like Odigos to manage it, you can really achieve a observability pipelines that is able to scale up and down and really support you whatever, no matter how high the traffic spikes can be.
You mentioned about Odigos, and I believe let's talk a little bit about that as well. It's an open source project. For folks who might be new to it, can you share a bit more about what Odigos is all about? And obviously, we talked about some of the challenges with OpenTelemetry. So maybe can you also answer how Odigos is solving those challenges?
Sure, of course. So basically, what we're trying to achieve with Odigos is, and again, we currently mostly focused on distributed tracing, which I think is like the best signal of all. Like it can really let you debug the application in a very deep way and really let you understand what the application is doing. The experience that we are trying to give users with Odigos is that basically we want to let you enjoy distributed tracing and experience distributed tracing without having to be an expert in OpenTelemetry, without having to be an expert in instrumentation, without having to be an expert in how the OpenTelemetry collector works and how to configure OpenTelemetry collector, without one of the underlying technologies that we are using in Odigos is a technology called EBPF. This is, for example, how we automatically instrument compiled languages like Go. And again, this is very low level technology. So again, this is all comes down to the final goal of like letting you enjoy this very high quality monitoring data, distributed tracing without having to know a single thing about either OpenTelemetry or EBPF, instrumentation, collector, any of this stuff.
Thanks for answering, Eden. And these are all nice questions. And by the way, for folks who want to get involved in Odigos, you can obviously check out, as I mentioned, the GitHub repository links in the description below. But when we talk about OpenTelemetry, we spoke about the challenges and all sorts of things. Are there any use cases where OpenTelemetry may not be suitable or where the benefits are limited?
So I think again, I think in take like a newer signal, for example, like profiling. I think some of the proprietary agents, let's take like Elastic or Datadog, may have a better solution right now than the OpenTelemetry solution. But I think eventually open source will win, and OpenTelemetry is getting there, and I think that we are making great progress in all the new signals and profiling, for example. So I think it really depends on the use case. There are some cases where the proprietary agent may be better. Again, they take profiling, for example, or some specific languages. I think like Ruby may have like a better proprietary support. But eventually, I think like OpenTelemetry is an extremely popular project. I think it's like the second most active in the CNCF after Kubernetes. So it will
You
catch up.
mentioned, yeah, you mentioned EBPF. They're also really taking off. I
Mhm.
see lot of monitoring tools utilizing EBPF. Um, so, anything you want to share on that area? How your experience has been with EBPF and why why you chose EBPF?
Yeah, sure. So
Not sponsored by Isovalent. I'm just curious.
Sure. So basically, in a sentence, eBPF is a technology in the Linux kernel that lets you load some sort of code into the kernel without having to recompile it or rebuild the operating system. And this code can be invoked by different kinds of events. It can be like a syscall. It can be like something that happens in user space. It can be something that happens over the network. And there are a lot of different kinds of events that can trigger eBPF programs. And this new capability to reprogram the kernel and react to different kinds of events really makes a lot of sense and opens a new opportunities, especially when talking about observability and security, because you now have this superpower when you can write code and be invoked on events that you up until a few years ago was not able to catch. So again, this is, for example, really powerful in programming languages that compiles natively, like Go or Rust, for example, where you don't have a runtime, you don't have something like the JVM where you can attach a Java agent. Now eBPF can give you a solution for that. You can load it to the kernel, you can load eBPF programs into the kernels that now are triggered by different kind of functions that are happening in the Go application, and this is how we're able to instrument compiled languages and really extend applications that are written in compiled languages, something that up until a few years ago was not possible.
Yeah, I met the Cilium EBPF folks at KubeCon, and they're doing like a lot of case studies now as well. So maybe I know I can connect you with them as well. Could be good for
Yeah, I
for
think Cilium is an amazing project. Like they do amazing stuff. Big fan of Cilium.
cool. Yeah. All right. They also did a children's book, so they're covering all the areas.
Yeah, it's correct.
All right. I want to talk a bit more about um, so after you've implemented, open telemetry, for example, what are some of the strategies or best practices that enterprises can employ to maybe, let's say, because it can get pretty complex to manage and maintain, right? So to simplify the management and maintenance of open telemetry in a large scale environment, like very large.
Mhm. I think one of the main concerns of organization after successfully adopting OpenTelemetry and enjoying logs, metrics, and traces and all these great telemetry data, now you're getting tons of value out of it, but soon your observability bill, your monitoring bill will now increase by 100% and now become much larger. And now you have to deal with all these new charges that you are now getting from your observability vendor. So I think one of the main challenges after adopting OpenTelemetry is how you are managing this trade-off between how much data I'm going to send to my observability vendor versus how much I want to pay for this amount of data. So I think that like tools that let you control the amount of data that you send to the observability vendors and tools that let you really see how much value you are getting, how many dollars are you paying for every microservices observability in your environment is a really powerful way, and I think really will let different kind of organizations not just, I think one of the key things that OpenTelemetry now enables is to quickly jump between different observability vendors. This is one of the big promises of OpenTelemetry. Things that if we now have also the ability to monitor the cost of the observability pipeline and the observability data, this will also give users a great experience and really give them a great way to evaluate different solutions and how much money they want to pay for how much value they are getting from every kind of observability tool.
Yeah, because it can get pretty complex real quick, and also on the cost analysis side. But one other thing that I want to talk about is this is the almost we're almost done with the episode, and then we'll talk a bit more about how to get involved with Odigos open source. But Always nice to talk about the potential security implications or risks that are associated with deploying open telemetry in enterprise environments. So, are there any such things, and how can these be addressed?
Mhm. Sure. So I think of one, if we are thinking about it from the security perspective, I think there are. I think the main concerns that I would have is that like leaking information that you're not wanting to log to export out to an external system. So like how am I defending myself from some developer in the companies that now added, I don't know, log lines that contains the user password, or like a new span that contains the credit card of the user. How can I add additional barriers in my observability pipelines that will uh, deny those kinds of data to leak out to external system and to leak data to external vendor. I think this is one of the main challenges when we are talking about with companies that are adopting OpenTelemetry these days.
So, to have like a system in place for every like stages, we talk about like some of the challenges, and we spoke about Odigos as well. For folks who want to get started and implement Odigos, how would you recommend them to get started? And obviously, I'll leave the links in the description. And how can they get in touch with you as well?
Sure. So basically, we have a GitHub repository. Installation is extremely easy. You can test it even locally on your local laptop via something like a kind Kubernetes cluster. It's we have the CLI. It's 2 clicks and you're down. You need to download our CLI, or you can install it via a Helm chart. It's a single command. You select which applications you want to instrument. You select where you want to send the data to, and we support, by the way, all the big vendors, also the proprietary ones, and also the open source ones like Elasticsearch, Grafana, Jaeger, Datadog, Dynatrace. You select where you want to send the data to, and that's it. You just now enjoy logs, metrics, and trace, and also a way to correlate and jump between the different signals. Reaching out to us is also very easy. We constantly monitor the GitHub issues, and we happy to get any contributions. And we also have a pretty nice Slack community that you are also welcome to join.
Amazing. So, thanks a lot for sharing, Eden. Really, had a great conversation. Thanks for answering all my questions patiently. But yeah, the conversation does not end here. Like Eden mentioned, you can carry it forward on Slack, and yeah, just check out the open source repository, give it a star, check out the issues, and use it out, and yeah, just contribute. So you can open a PR if you see something that you can contribute towards. But obviously, um, follow the open source best practices. But yeah, really looking forward to it. I will, we'll catch you up on Slack, and you'll see more such episodes coming from Team Odigos and me. We're planning some nice things, but really a lot of fun, and yeah, a lot of opportunity, especially because these things can get complex really quick. And yeah, I think we can go for on and on, like talking about
Yeah.
um, the whole landscape, and where Odigos fits in. But I think we'll keep it here for now, and see you in the next one. Have a great day. Bye.
Bye. Thank you.